Hey everyone, Chang here and welcome to my channel. This is the Bare Minimum Algebra series. Today we're going to focus specifically on the integer numbers. Now, integers numbers. There is three criteria for making a number an integer, right? It is either in the positive whole number group, so basically 1, 2, 3, 4, 5, 6, so on and so forth, your counting number, your natural number. You have the negative whole number groups, basically the counting, or I guess you could say natural number. However, it's the negative variation of it. So instead of just 1, 2, 3, 4, 5, 1,000, 5,000, so on and so forth, right? You have your -1, -2, -3, -4, -5, -1,000, -1,000,000, so on and so forth. And lastly, you also have the number 0. So those are the three categories. If a number falls into one of these three categories, it is considered an integer. So let's look at examples of each of them. The first one, positive whole numbers, fairly simple. Once again, 1, 2, 3, 4, 5, so on and so forth. Easy stuff. Negative whole numbers, -1, -2, -3, -4, -5, so on and so forth. Easy stuff, right? It can go on forever positively, it can go on forever negatively. The key is also that the number 0 is included as well, so 0 is part of the integers. Now, these examples are easy because it's blatantly obvious these are whole numbers, these are negative whole numbers, and the number 0. What's not so easy is when it's not obvious. So for example, here's one. 6 divided by 2, or 6 over 2, right? This as a number. Now, if you've watched my previous video of the 6 simple number system, this one would be screaming rational number to you. However, this is also considered an integer. Because guess what? When you simplify this, basically 6 over 2, or after you carry out the division, it is 3. 3 itself is one of these three categories. This one mainly. And so, hence, it is an integer, right? So you can have a bunch of different fractions written in crazy, weird way, and they might potentially be integers if all of a sudden, after you divide them, after you simplify them, they're one of these three categories, right? And then of course the other thing I should mention is decimals that you would encounter. Like 6.25 is definitely not one of them, but if you have 6.000 just because someone wants to put it that way, or it's in a computer system or whatsoever and they want it in 3 decimal places, this is still technically a whole number, so technically still an integer. Now when you're counting the integers, the positive whole numbers, negative whole number, and 0, you also encounter situations where you need to graph them. The graph is fairly simple. You always pick one point, usually the center, and that's where you're going to put 0. All on the right is your positive numbers, all on your left is your negative numbers. Now, you just find equidistance, however, basically the length you want to separate them, make sure it's the same amount every single time. And then you just start going forward. So if I choose this as my length, this is 1, same length roughly, this is 2, same length roughly, it's a 3, and so on and so forth. The opposite, right, to the left hand side, same length is -1, same length is -2, same length is -3, and it goes on, so on and so forth. So this is how you would graph an integer. All right, so there you go. This is a quick short video on just integers, right? What are the requirements for a number to be considered an integer? Whole numbers, positive, whole numbers, negative, 0. Any numbers that can be written as one of these three categories, even though initially it might not look like it, right? If it could be written in one of these three categories, then they are an integer. Plain and simple. Now, common mistake, once again, if it's a fraction in any way, be very careful, it might be an integer. The second common mistake is in relation to graphing integers. Graphing integers, fairly simple. You pick a point, usually the center, call that 0. Everything on the right hand side is positive, everything on the left hand side is negative. The key The common mistake is that you have to make sure every separation is equidistant, the same length every single time when you're graphing it. If you're not, if all of a sudden 0 to 1 is one length and then 1 to 2 is some giant length or shorter length, then it makes no sense, right? You're going to throw everyone off. That's not a good graph, even as approximation. So try to make it as equidistant, the same length as possible. But other than that, fairly simple. 0, right-hand side positive, left-hand side negative. Go on forever until you really want to stop. And there it is, right? Thank you for watching this video. If you haven't already, please like, comment, and subscribe. I will see you in the next video.